This section sets the stage for the quiz. It presents a machine learning scenario involving a dataset with 1,000 samples and 4 classes, A, B, C, D, with unequal sample sizes. The core task is to understand how the "RepeatedStratifiedKFold" function in scikit-learn would handle this imbalanced dataset when performing 5-fold cross-validation with 3 repetitions. This line provides details about the dataset that is being worked on. There are 1,000 samples. The distribution is imbalanced, with Class A having 200 samples, Class B 300, Class C 250, and Class D 250. This imbalance is a crucial factor in choosing the right cross-validation technique, which is repeatedly stratified K-fold validation. This specifies the parameters used in repeated stratified K-fold. The cross-validation will use 5 folds, meaning the data will be split into 5 parts. The entire process will be repeated 3 times, with a different random shuffling each time. This ensures the model's performance is robust and not just based on a single random split. Repeated stratified K-fold helps to address the imbalanced nature of the dataset, ensuring that each fold reflects the class distribution as much as possible. This introduces the quiz, indicating that the following lines will present a multiple-choice question based on the dataset and cross-validation parameters. This line poses the central question of the quiz. Determine which statements correctly describe the characteristics of the folds generated by the repeated stratified K-fold process with the given settings. This is the first multiple-choice option. The statement suggests that each of the 5 folds will have roughly the same proportion of samples from each of the 4 classes, A, B, C, D. This relates directly to the stratified aspect of "repeated stratified K-fold". The second option claims that the folds will be identical across all 3 repetitions. This is a critical point to test the understanding of how the "repeated stratified K-fold" function incorporates randomness. This option explores the role of randomness in the repetition process. "Repeated stratified K-fold" shuffles data before splitting it into folds in each repetition. It asks whether this random shuffling is different for each repetition. The problem statement specifies that the repeated stratified K-fold cross-validation will use 5 folds and 3 repetitions. This means the data will be split into 5 parts 3 times, each time with a different random shuffle. This setup is key to understanding the number of training and testing sets generated. The 5 folds refer to the number of times the dataset will be split into training and testing sets in each repetition. In each repetition, the dataset is divided into 5 parts, with 4 parts used for training and 1 part for testing. The 3 repetitions indicate that the entire 5-fold cross-validation process will be repeated 3 times. Each repetition starts with a different random shuffle of the data before the splits are created, leading to different training and testing sets. This enhances the robustness of the evaluation by reducing bias from a single random data split. This is the scikit-learn function used in the problem. Repeated stratified K-fold performs stratified K-fold cross-validation multiple times. Repeated means it does the splitting multiple times. Stratified means it maintains the proportion of each class in each fold. K-fold means it creates K splits, folds, of the data, using K1 for training and 1 for testing. Since there are 5 folds and 3 repetitions, there will be a total of 5 folds * 3 repetitions equals 15 training sets and 5 folds * 3 repetitions equals 15 testing sets. This is because each of the 3 repetitions generates 5 folds, each with its training and testing sets. The dataset contains a total of 1,000 samples. This is the overall size of the data used for the machine learning project and is important for understanding the scale of the cross-validation process. It's a decent-sized dataset, big enough for the repeated stratified K-fold to be effective. The target variable in the dataset has 4 classes, A, B, C, and D. The distribution of samples across these classes is imbalanced. Class A has 200 samples, Class B has 300 samples, Class C has 250 samples, and Class D has 250 samples. This imbalance is crucial because it directly impacts the choice of repeated stratified K-fold for ensuring fair representation of each class in cross-validation folds. The imbalanced nature of the classes is something to pay close attention to. The repeated stratified K-fold algorithm will use 5 folds, n_splits equals 5, meaning the dataset will be divided into 5 parts for cross-validation. Each fold will be used once as a test set and the other 4 folds as training sets. Additionally, the cross-validation will be repeated 3 times, n_repeats equals 3, with different random shuffles of the data each time. This repetition helps to get a more robust estimate of the model's performance and reduces the impact of any single random split. Repeated stratified K-fold is a cross-validation technique from scikit-learn. It's designed for datasets with class imbalance, such as this one. The repeated part means the cross-validation process is repeated multiple times with different data shuffles. The stratified part means that the class distribution is maintained in each fold. It's a very smart way to handle imbalanced data and get a more reliable evaluation of your machine learning model. Since there are 5 folds and 3 repetitions, a total of 5 times 3 equals 15 training sets will be created during the cross-validation process. Each repetition uses a different random split of the data, leading to a different set of training data in each iteration. That's a lot of training to get a better picture of how well the machine learning model performs. Similarly, there will be 5 folds *3 repetitions equals 15 testing sets. Each fold serves as a testing set once in each repetition, which provides multiple evaluations for better model assessment. This gives you a solid way to determine how well your model is going to generalize to unseen data. Because repeated stratified K-fold uses stratified sampling, each fold will have approximately the same proportion of samples from each class, A, B, C, and D, as the original dataset. This is crucial for unbiased model evaluation, especially with imbalanced datasets. This is really important for avoiding biased results. The key feature of repeated cross-validation is that the data is randomly shuffled before each repetition. This ensures that different folds are created each time, providing a more robust evaluation of the model's performance and reducing the impact of a single random split. It helps avoid being overly reliant on one particular random split of the data. That's right. Since we have 5 folds and 3 repetitions, we multiply those numbers together to get the total number of training sets and testing sets. 5 folds *3 repetitions equals 15 of each. Each repetition will create a complete set of training and testing data. This specifies the number of repetitions in the repeated stratified K-fold. The process of splitting the data into folds and training, testing the model is repeated 3 times, each time with a different random shuffling, to enhance the robustness of the model evaluation. The total number of training and testing sets is a direct result of 5 folds and 3 repetitions. It is important to understand that each repetition generates a new set of folds, leading to 15 distinct training sets and 15 distinct testing sets in total. This line describes the core process. The dataset is repeatedly split into stratified K-folds. Here, K equals 5. Stratified means that the proportion of each class, A, B, C, D, is approximately maintained across all folds. This helps prevent bias in model evaluation. The dataset contains a total of 1,000 samples, which will be divided into folds for cross-validation. This is the total amount of data being used in the machine learning project. This is important to consider when determining how many samples will be included in each fold and test set. There are 250 samples belonging to Class D along with classes A, B, and C. This class contributes to the overall dataset's imbalanced distribution. The presence of this class, and similar distribution of others, will be relevant to understanding how well the repeated stratified K-fold maintains class proportions in its creation of test and training sets. The dataset will be split into 5 folds. In K-fold cross-validation, where K equals 5 here, the data is divided into 5 parts. Each fold will be used once as the testing set, while the remaining 4 folds will form the training set. This process helps assess how well a model generalizes to unseen data. Think of it like testing your knowledge with 5 different quizzes, each quiz using a slightly different combination of your material. The 5-fold cross-validation process will be repeated 3 times. Each repetition involves randomly shuffling the data before creating the folds. This helps to reduce the impact of the initial random split on the cross-validation results, providing a more robust estimate of model performance. It's like taking those 5 quizzes 3 times, but each set of 5 quizzes is created in a slightly different manner. Exclamation mark. Since there are 5 folds and 3 repetitions, a total of 5 folds * 3 repetitions equals 15 training sets will be created. Each training set consists of 4 out of the 5 folds of the data during each repetition. Similarly, there will be 15 testing sets, 1 for each training set during each of the 3 repetitions of 5-fold cross-validation. Each testing set is simply the remaining fold left out from the training set during each iteration of the cross-validation. This is the RepeatedStratifiedKFold technique we're using for cross-validation. It's a powerful method to evaluate a machine learning model's performance, especially with imbalanced datasets like ours. We'll be splitting our data multiple times to get a more robust measure of how well our model generalizes. Here's where we define the specific parameters for RepeatedStratifiedKFold. We'll use 5 folds, meaning our data will be split into 5 parts, 4 for training and 1 for testing. And this process will be repeated 3 times with different random shuffles to get a more reliable evaluation. Think of it like running the same experiment 3 times with slightly different data each time, giving you a more stable result. Since we have 5 folds and 3 repetitions, that means we will produce 5 times 3 equals 15 different training sets and 15 different test sets. Each repetition uses a different arrangement of the data, leading to 15 different model evaluations. This gives us a much more comprehensive idea of how our model performs. It's like taking multiple snapshots of our model's capabilities across different subsets of the data. This highlights the stratified part of RepeatedStratifiedKFold. It ensures that each fold has roughly the same proportion of each of the 4 classes, A, B, C, D. This is really important because we don't want to accidentally end up with a fold that's heavily biased towards one class. That would skew our performance estimates. The repeated part kicks in here. Each of the 3 repetitions will shuffle the data differently before splitting it into folds. This means that the training and testing sets will vary between repetitions, which helps us get a more stable and realistic picture of model performance by accounting for variability in data.